Hello again. Here for a little bit of help on Chang 6.36. So this was the problem about you had a block of iron and a block of gold, and there was heat transfer here. And what you're interested in is what is the final temperature of both blocks, okay? So we can say this kind of statement. We can say the final temperature of gold is equal to the final temperature of the iron, all right? And we're going to use some of the same equation we used before for heat or heat transfer, and that's that the heat transferred is equal to the mass times the specific heat times the delta T. Okay, so this is what we're trying to find, the final temperature. We're given the initial temperature, but we're not really directly able to calculate delta T, so we're going to leave delta T as the mass times the specific heat times, remember delta T is really the final temperature minus the initial. Okay, so this is the form of the equation we'll use right here. All right. So we do know some information about our two samples. So the gold has the mass of gold is equal to 10.0 grams. The initial temperature of the gold is 18.0 degrees Celsius. And the specific heat, if we looked it up on the table that it pointed us to, is 0.129 joules per gram degrees Celsius. Okay, we also have information for the iron. The mass of iron is 20.0 grams. The initial temperature is 55.6 degrees Celsius, and the specific heat is 0.444 joules per gram degrees Celsius. Okay, so we have a lot of the information we need, so we can make this sort of statement. We can say that the heat gained, this is going to be the heat gained by the gold, equals ms equals this, the mass times specific heat times the change in temperature. So we're going to get 10.0 grams. I'm going to start over so I have enough room to do this. So the heat gained by the gold equals 10.0 grams times 0.129 joules per gram degrees Celsius times, now we have to leave it in this form, the final temperature minus 18.0 degrees Celsius. Okay, so the heat, this is heat gained by gold, and we can also say the heat lost by the iron is 20.0 degree, or 20.0 grams times 0.444 joules per gram degrees Celsius times the final temperature minus 55.6 degrees Celsius. Okay, now the hardest part of this is to say, well, what do I do with these? What we can say is that the heat gained by the gold is equal to the heat lost by the iron, right? So this is positive, this is negative, or we can say the heat gained by the gold plus the heat from the iron equals 0. Okay, so this is really, getting here is really the hardest part of this problem. The rest of it is a little bit of algebra. Okay, so what we can say, if we go ahead and multiply this out, what we get is 1.29 times the final temperature minus 23.22 joules plus 8.88 times the final temperature minus 493.7 joules is all equal to 0. Okay. Again, so what we get here is we get, if you add these, you get 10.17 times the final temperature minus 516.9 joules equals 0, or 10.17 times the final temperature equals 516.9 joules. Divide both sides by 10.17 and you get that the final temperature is equal to 50.8 degrees Celsius. Okay, again, that one was on the harder side, especially, understanding this relationship here. In this example, we assume that no heat was lost to the environment. Anyway, otherwise we can't solve it. Hope this was helpful, and if we need to work on this more, we can do it when we see each other.